So in this case we will see the elastic behavior of composite in transverse loading. A continuous and oriented fiber loaded may be like this in the matrix, and the loading direction is this. So the fiber is oriented to the loading direction at a 90 degree. So we will see here that the sigma C is equal to sigma M is equal to sigma F equal to sigma. So this is also called the iso stress condition. And to calculate the elastic modulus of composite in transverse loading, this is also the name for this, and it is also this race model and perpendicular to the fiber condition. These are also the synonyms for this condition and transverse loading. So the formula will be here 1 upon EC is equal to Vm upon Pm plus V of F upon P of F, which is elastic modulus of composite, elastic modulus of matrix, elastic modulus of fiber. This is the volume of matrix, this is the volume of fiber. So we can calculate the elastic modulus of composite in case of transverse loading with this formula. In this slide we will see this Chornev rule. So the time required for a simple casting to solidify completely can be calculated using this rule. So this rule shows the time required, Ts is equal to B multiplied by V by A to the power n, where V is the volume of the casting, represents the amount of heat that must be removed before freezing occurs, and A is the surface area of the casting in contact with the mold, represents the surface from which heat can be transferred away from the casting, and n is a constant, so usually n is taken as 2, and this B is the mold constant. And secondary dendrite arm spacing, SDAS, this is related to the solidification time by this formula, S dash is equal to K to the power M, where Ts is the solidification time and M and K are the constants which depends on the composition of metal, like this is written here, composition of the metal. And now we will see the Sievert's law. So usually in gate examinations we see the numerical on these important laws. So the amount of gas that can be dissolved in molten metal is given by the Sievert's law. So percentage of the gas dissolved in the molten metal is equal to K into under root of partial pressure of that gas. So P gas is the partial pressure of the gas in contact with the metal, and K is constant for which this one is the constant for a particular metal gas system increases with increasing temperature. So these are the three important formulas which we use. And one more, this is the Gibbs phase rule. This is the very important. So Gibbs developed the phase rule in 1875 and 1876. So it describes the relationship between the number of components and number of phases for a given system and the condition that may be allowed to change. So what are the parameters? So these are the temperature and pressure. These are the two parameters. It has the general form of like F is equal to C minus P plus 2. This is the general formula for Gibbs phase rule, where F is the degree of freedom or number of variables such as temperature, pressure and composition, so that are allowed to change independently without changing the number of phase in equilibrium. That means with changing these three parameters the phase will not change. And C is the number of chemically independent components, usually elements or compounds in the system, and P is the number of phases present. So this is the composition, this is the this is the component, and this is the phases, number of phases, and this is the constant parameter, which is generally temperature and pressure, which are allowed to change. And this condensed gives phase rule given as a F is equal to C minus P plus 1, in which case the 1 is taken here because most generally all the metallurgical reactions happens at a fixed pressure. So here this 2 changes to 1 because pressure is fixed, so this will be F is equal to C minus P plus 1. So this is the formula is taken here for the condensed gas phase rule. Generally we take, in case of single component system, this formula F is equal to C minus P plus 2, and for condensed system like binary, ternary and so on, we will take this F is equal to C minus P plus 1. So thank you.